Hi, today we are going to be doing something different in DIgSILENT, something that is not usual for this software. I create a script in which we simulate the old snake game, which all of us had on the phone at the point in life. I create this snake game, and I try to teach the snakes to play the game by himself, thinking by himself. He is going to learn how to walk on the environment, and to avoid hitting the wall, and to eat as many apples as he can, just thinking by himself. So for this, I create a script that is simulating the environment. The environment being only this plane, this Cartesian plane, with x and y coordinates. The snake is just a simple matrix. I'm going to show it to you. So the snake is here. So it has two columns. Column 1 is for x coordinate, and second column is for y coordinate from the Cartesian plane. And the foot also is just a simple matrix with two columns and one row. The same thing, one is for x coordinate, and column 2 is for y coordinates of the Cartesian plane. So further, we are going to see. I'm going to show you how I did it step by step. So the whole process of reinforcement learning is about putting the agent in the environment, the agent being the snake. So putting the agent in the environment, and the agent must walk throughout it without crossing the environment boundaries, and eating as many apples as he could. For this, the snake or the agent has a brain. The brain being the neural network, a typical neural network. At each time step, the neural network is going to be fed an input vector, which the information contained in this vector are going to be where are the walls, if the snake is close to the wall, or where is the apple, or if he's close to its tail, or all kinds of information. This vector has a dimension of 11 binary variables. We are going to speak about it later on. And at the output of the brain of the neural network are going to be three actions. The snake is going to take a left turn, or right turn, or is going to go straight. At each time step, if the snake eat an apple or dies, he receive a reward. In the case of eating an apple, he will receive a reward of 1. If he is going to die, I mean, if he's going to hit the wall or he hit himself, he's going to receive a negative reward of -1. And based on this reward, the weights of the neural network are going to be slightly changed with each time step using the Bellman equation. So in other words, with this reward being negative or positive, the snake will learn to not take, or to take, that action that he previously took. To make an analogy, this process is like a human driving a car. So a human, when he drives a car, he receives some information at each time step throughout his vision. So the human knows where the lane is, if he's close to the left sidewalk, or the right sidewalk, or if it has a car in front of him. So the same thing happens here. The snake at each time step through this environment, he received some information, so-called an input vector, which we are going to see this vector in content here. We're going to look in here in this matrix. This matrix is the input vector. Yes, the input vector of the snake's brain. So it has 11 binary variables. 3 of them are this is all these variables are reported to his head. So if danger is in left of the snake's head, or the danger is straight of the snake's head, or in the right, is going to be 1 here. Other 4 variables are going to be the direction in which the snakes is going. So if he's going into in the west, if he's going to north, east, or south, it's going to be 1. So here in this case you can see that he's going in south. And then the last 4 variables are where the apple is in the west, and the north, east, or south of his head. You see, in this case the apple is going to be in the west, northwest of his head. So this is the input vector. Now we are going to see the output vector is here, is this matrix. We have 3 values: left, for straight, and right. The biggest value is the decision that the snakes will take. In this case, she's going to make a left, because the values for left is the greatest. Now let's start the learning process. So we are going to simulate 1000 episode, 1000 games, in which the snake will walk throughout the environment and try to not die by going outside the environment boundaries, and to try to eat as many apples as it can. So for this I'm going to execute. You can see that the snake is randomly exploring the environment, and when he's going outside, he's going to die. So you can see at the game 8 he ate an apple. Here are going to be displayed some information. Only the episode in which he is going to eat at least 1 apple. Okay, so now we are going to look a bit inside the flowchart. Okay, here in description I'm going to put the windows here. So as we can see, we have 2 loops, one for each episode, for each game, and 1 while loop for each step. Yes, the step loop is where the snake is going to be to learn. So first, at the beginning, the weights of the neural network are randomly initialized. In the game loop, the snake is going to be initialized. Also, the food is going to be initialized in this loop. Now, in the step loop, while the snake is alive, we are going to determine the initial state S1. Actually, S1 is the input vector, what actually he sees. So S1 is, as I showed you previously, is this. Is all this information about where are the walls, where is the food, where is he heading. Okay, then based on this input vector, the snake is going to take an action. So via the epsilon greedy algorithm. So at the beginning of the learning process, this action are going to be random, but once the process is closing to finish, is going to be to finish, the action are taken more and more by snake's brain. Then the snake moves according to the action that the brain decided to take. Get the reward. Then determine S2. S2 is the input state after the snake move from previous state, from S1. Yes. So we are going to save this tuple in D. Yes. We are going to save S1 direction out, reward R, and input the vector s2. Yeah. So while the snake ate, we determine s1 is going to take an action via the brain of the snake, not the epsilon greedy. Move the snake according to the action, get a reward, determine s2, and also we are going to save this tuple. Then if the snake ate, increase the snake size with 1 and initialize the food, a random initialization of the food. Now we have another loop in which we are going to actually this is the loop in which the snake learns. Is going to be taking a mini batch from D, and for each tuple from the mini batch we are going to calculate the loss between output Q and target Q values. We know that in order to the neural network to learn, we must have an output and a target. Okay, so we are going to update the weights of the neural network with a gradient descent. Actually, at a certain after a certain number of steps, the weights of the brain are going to be updated. We can see here we have brain 1 and brain 2. Actually, we do not have two neural networks, but we have two sets of weights. Yes, and here we have mini batch loop in detail. You can pause and you can see it by yourself how actually the backward propagation is done and how the Bellman equation it is used in. You can see it here, how it is implemented. You can pause here. Okay, let's see now where we had it. You can see that we are at the game 224. You can see that episode he ate 3 apples, so it's a top score. So slowly but surely the snakes learn. Now we are going to look a bit later to see how the snake to see the progress of the snake. We can see now that we are at episode 414. You can see that we have a top score of 15. So let's look at the progress. You can see how slowly the score per episode increases. You see, slowly but surely, 292. You see, we have a score of 4, and it's increasing 7, 8, and 12 at 357. So gradually, the weights of the neural network of the snake are tuned so that he learns to avoid getting out of the environment, and also to go toward the apple and to eat as many apples as he can. So you see that he's quite large, and yeah, at a certain point he dies by entering a kind of a loop without exit, or he bumps into the wall. Yeah, because we still have random action from the epsilon greedy algorithm, because we are still at the beginning of the game. So we are going to see at the end of the learning process to see actually what is the top score of the snake. So we are at the end of the optimization process. You can see that the top score is 27. It means that in a certain game the snake ate 27 apples. So you can see the duration of the whole process was learning process was 87 minutes. We can see that sometimes we get this message: too many steps without eating. This means that then the snake entered in an infinite loop. It was working in circles. So to avoid this, I put a condition. So if the snake doesn't eat nothing for a certain number of steps, he dies, and a new episode starts. Okay, so now let's play a game. So making this variable 0. Now if I execute the script, the snake will play a game, eating as many apples as he could. Now the snake is thinking by himself, so at every step he's taking his own decisions. We can see that he is nicely avoiding the walls and going straight forward for the food. He's getting bigger and bigger. We can see that in the output window we have some information that I will later explain them. He's going to be, yeah, at a certain point, at the top score of 30, very good score, he entered in a loop. Yeah, he entered in a loop. But to avoid this, we could enhance the score by putting another another 2 inputs. So let's presume that the head of the snake would be here at a certain point, and he would going in the west. Yeah, the direction of the snake was west. So the head of snake was here, so he choose here to make a right. If he had another 2 inputs, like for example at each time step, if in his right or left, he would intersect his body, then would be 1, and if he's not intersecting his body, you see in the left side, it would be a 0. So with these two, adding these 2 information, at a certain point he would here he would make a left and get out of this loop. Now let's explain this information here. So let's take, for example, this bit of information. We have here S1, the initial state. Here is the of the snake, of the head of the snake. This is the coordinate of the snake, of the head of the head of the snake, 8, 9. So when this is the information when the head of the snake was here, exactly in this point, 8 with 9, yes, here. The direction that he took, he was walking forward, yes. You can see that after he was here, he went straight forward, and this is the information. Here's the final step, S2, where the head is here, and the head, the coordinate of the head is 9 with 9, 9. So 9, 9. And what happened? The reward was -1. Yeah, this is the information. So we have the information at each time, at each step the snake walked. So for instance, here R being 1, it means that he ate an apple. What is interesting about the inputs of the snake, the inputs that he received at each time step to his brain, is that if we place the snake in a much larger environment, he would behave the same as he was taught in a environment of size 10. So he was taught in an environment of size 10. Now if we are placing him in a, let's say, size of the environment making 25, and also must modify here and steps without eating 350, we would see that that the snake behaves exactly the same as when the size was smaller. So execute. Okay, we can see that he's going straight for the food and avoiding the walls. Yeah, until he finished, let's speak about a bit about the variables. Play or learn. If he's playing a game, he's 0. If he is learning, 1. And episodes means how many games he would play when he learns. And steps is number of steps without eating. Delta in this case is 100. Number of games going to copy the weights to one neural network to other. Learning rate of the neural network is 0.1. Gamma is the discount rate used in the Bellman equation here. Okay. Explore rate, max exploration rate, minimum exploration rate, exploration decay. Those are variables for the epsilon greedy algorithms. Okay, n is the number, the number of tuples saved, so the size of the memory plate. N batch is the size of the mini batch. N layers, how many layers the brain has. In this case, is 3. A number of neuron on the hidden layer is 15 in this case. The activation function is 3, meaning that is going to is tangent hyperbolic. So the activation function used is the tangent hyperbolic. Environment size is 25. On off plot, this is an option. If is one when he's learning at each time step the snake would be displayed. If he's 0, he will not be displayed because he's much faster. W update is 4 here. Number of steps until the weights are updated on the neural network. Okay, we can see that the snake enter also in a infinite loop, and he dies making a score of 41. Okay, so that's it. Thank you very much.